Bhagirat, good morning. Bhagirat, Deepak,
Morning, sir.
can you have another
Sir.
quiz too, so that you can have some idea about the question pattern. See, you don't have to think about the marks, how much you got. You don't have to bother about that. But the pattern of the question is very important for your end semester examination. So I was thinking that maybe two, three, four quizzes if we can conduct, then it will probably help you in your final exam and semester. So this Saturday, let us hold another quiz number two. Am I audible? Deepak, am I audible?
Yes, sir.
Yeah. So let's have a quiz on this Saturday.
Okay.
So on this Saturday, we'll have another quiz. Why? Because your syllabus is almost over. So many things have been done, and your classes were not missed so much. So okay. So Saturday, be prepared. The questions will be same only of this type. Okay. Let me share my screen. So today we will cover some basic definition of material properties. Okay. So these things you know, the terms, the different names you know, but I wanted to give you some bookish definition about that. Okay, so in many exam, or if you see appear in GATE exam, if you appear in any competitive exam like in this engineering exam now, so there this type of questions may come, or you may be asked in your interview. So let us do it. So, properties of material. Properties of materials. Number one, elasticity. So you write down elasticity is the property by virtue of which a material is deformed under load and is unable to return and is unable to return to um, its original dimension when the load is removed. when the load is removed. Number two, you write plasticity. Is the converse of elasticity. A material is in plastic state is material in plastic state is permanently deformed by the application of load application of load, and it has no tendency to recover. The characteristic of material uh, material the characteristic of material by which it undergoes which it undergoes inelastic strains beyond those at plastic limit limit is known as plasticity. Next, you will write ductility. This is the characteristic with which one is the characteristic which permits the material to be permits the material to be drawn out to be drawn out longitudinally to reduce section Reduce section under the action of a tensile force. But this tensile force is very large, so large deformation occurs. Number four, brittleness. So the brittleness it implies lack of ductility. The material is said to be brittle means said to be brittle when it cannot be when it can't be drawn out by tension. By tension to smaller section. Number five, you write malleability. It is the property of a material material which permits the material right, which permits the material to be extended in all directions to be extended in all directions to the rupture. Rupture means fracture. To the rupture. Or you can write it fracture. Rupture or fracture. Malleable material possesses a high degree of plasticity. But not necessarily great strength. But not necessarily great strength. Constant. Next to write toughness. Is the property of a material which enables it to absorb energy without fracture. Without fracture. Number 7. Hardness. Is the ability of a material which to resist indentation. To resist indentation. Indentation means marking, you can say in simple language. Indentation or surface aggression. Renal hardness test is used to check hardness. Another test is also there, Rockwell test. Used to check hardness. The renal hardness number. Renal hardness number. We say BHN is equal to P by pi B by 2 D minus root over capital D square minus small d square. Bracket close. Where P is your standard load. Capital D, diameter of the bowl, means there is a diameter. There is a diamond ball actually for making that indentation. So now this D is the diameter of the bowl, we can say simply. Diameter of the bowl. Then steel ball, you can say steel ball also, or sometimes it is also diamond ball. And small d is the diameter of the indent. I will come to this point. Diameter of the indent. Okay. So let me come one by one. Am I audible? Now I have to speak actually. Hello? Am I audible? So first of all, you have elasticity. So elasticity is a very basic property of any material. So elasticity can be defined as the material property by virtue of which if you pull or push something with some load and go up to a certain level or certain load, after that you remove it, if it is an elastic material, then it will regain its original dimension as soon as you remove the load. Okay, so likewise we can define plasticity. If you further go on increasing your load and you remove it, it will persist or it will require a permanent deformation in that particular material, and that property is called your plasticity. So this is very simple. So ductility also you are knowing about that. Ductility means the material, suppose aluminum, suppose magnesium, these are ductile material. Why ductile? Because the property is like if you pull one, suppose iron rod, if you pull it with a tremendous force, then you will see that its length will go on increasing, but its radius will reduce. Okay, its radius will reduce, and finally you will get a thin wire. That initial bar or rod, you can get it as a thin wire, like where you use in tightening the fencing, not fence in our home. So that wire is made of actually steel. But initially it was not like that. Initially it was a bar. Then you pull it with tremendous force, heavy load, and you will get your wire. So that particular property, if you pull it with a very huge force, but it still can resist that particular load and it changes its dimension, that particular property is called ductility. And brittleness is the opposite of that. If you pull it, it may get fractured or ruptured. Okay? So ductility property is also important in some cases. In some engineering application, brittleness is also important. Okay? So then malleability. Malleability is the property. See, you can give it to any shape after heating it. Okay? So this particular property you can enjoy it in blacksmithing. If you look at the blacksmith, what they do, they first red hot the iron and then they use the hammer to make it different shape, because you have different shape of knife, different shape of eggs. So those things actually, that property is called malleability, by which you can give it different shape. Then toughness. So toughness and resilience are almost same, but there is a thin line difference. Resilience is the area under the stress strain curve, but toughness beyond elastic. So it is the property of absorbing energy, toughness. So earlier I also mentioned about toughness and resilience. Then hardness. Hardness is that suppose you have a soft material, any material, suppose wood. So that you can actually keep, what you can do, you can take out its bar, or you can do any surface abrasion on that particular wood or some soft material. But suppose it is a very hard material, for example, suppose quartz, okay, or suppose maybe something. So there you cannot take out its abrasion. You cannot do any surface preparation on that particular material. So hardness is the ability to resist indentation. Indentation means it resists to make any mark on its surface. Okay. So for that, to calculate or to know the hardness of different material, we have some instruments like Grinnell hardness testing, Rockwell hardness testing. Okay. So the formula for Grinnell hardness test, what we call BHL, is given as I have shown. Okay. So it is like this. So there are, if you see, there are two D, one capital D, one is small d. So what is it actually? So let me just tell you. Suppose you have a material. This is a material. And you want to see its BHN. BHN you want to see. So there is a instrument like this. At the tip there is a small ball. Okay. So you now hit it with this one. So this is actually capital D. The diameter of this ball is capital D, and due to indentation it will create something like this. Okay, so this is another curve now. So it has also got some radius, and that is your small d, and P is the load by which you are applying. Okay, that's fine. So this is what. Okay, let me go to another thing now. Small thing, but very important thing. Just write the definition, and the small formula is there. Right. Principal stresses and principal plans. So this thing already I have discussed in more circle. So, but that was graphically. Now you can do it analytically. Suppose this is your object. This is shear force tau. It will always create one couple. This is suppose sigma 2. This is suppose sigma 1. And this is suppose, sorry, this is also sigma 2. This is suppose sigma 1. And this is also sigma 1. Okay. So let us consider one section, oblique section. Fine. So suppose this angle is theta p. Now let me draw the free body diagram of this. This is the original diagram, and now let me draw the free body diagram. So your section is like this, oblique. So definitely this will not be sigma 2 but sigma 2 dash. This will be sigma 2 dash. This will be sigma 1 dash, sigma 1 dash. Okay, this is the free body diagram. Okay, so this angle again your theta p. Fine. Okay, so this is sigma 1. Okay. Now come to the definition. The plan carrying the plan carrying the maximum normal stress maximum normal stress is called the major principal plan. And the normal stress is called major principal stress. the plane carrying the minimum normal stress is known as minor principal stress. So measure principal stress in the oblique plane stress sigma 1 dash is equal to sigma 1. So this is same formula only, but this is analytical. Sigma 1 plus sigma 2 by 2 plus root over sigma 1 minus sigma 2. This you have to remember. It's important from numerical point of view. Plus tau square. So this is measure. We have another one. Minor principal stress. Minor principal stress. Sigma 2 dash is equal to same only negative sign. Sigma 1 minus sigma 2 by 2 minus root over sigma 1 minus sigma 2 by 2 whole square plus tau square. Okay, so this is it. Okay, so now can I stop sharing? Wait, I'll take the attendance. I have not taken the attendance.